Okay, so this is question 2, and this question is from topic 3. It's thermal physics, so let's quickly read it. So define internal energy. So it wants a definition for what internal energy is. Well, internal energy is the total or sum of all of the kinetic energy and the potential energy, and that would give you 1 mark, of all the particles in an object. So there's 2 marks here, 1 for this bit and then 1 for this bit. The second question is, let's have a quick read through it. 0.46 moles of an ideal monatomic gas is trapped in a cylinder. The gas has a volume of 21 meters cubed and a pressure of 1.4 pascals. So let's just put something, now that's N, that's what represents that. V, volume, yes, and I've got P for pressure. The question is, state how the internal energy, the first part anyway, how the internal energy of an ideal gas differs from that from a real gas. Well, for an ideal gas, it's assumed that there are no intermolecular forces acting. So for an ideal gas, the intermolecular potential energy is 0. It only has kinetic energy. So kinetic energy, the total kinetic energy of all the particles in an ideal gas is equal to the internal energy of the ideal gas. So let's have a look at the calculation now. It says determine in Kelvin the temperature of the gas in the cylinder, so that's capital T. So it's obvious here then, looking at the data I looked at before, that I'm going to use the ideal gas equation, PV equals nRT, rearrange it to make T the subject, and put the numbers in. So I already know from previously that the pressure was 1.4 pascals, that's an SI unit, that's okay. The volume is in meters cubed, 21. The number of moles is 0.46, and this is the molar gas constant, 8.31 from my data booklet R. And my answer will be in Kelvin, and it becomes out at 7.7. Finally, for this question, this is a nature of science question. And the question is, the kinetic theory of ideal gas is one example of a scientific model. Identify one reason why scientists find such models useful. So you've got to be quite, you haven't got to be specific here, because it is a nature of science question. So you've got to say, what models are useful and why they're useful. So models, any of these would do. So models are used to predict, hypothesize. They're used to explain in more detail, help us understand physical concepts in more detail. They help us visualize them sometimes, or simulate difficult concepts, or simplify. And I suppose in this instance, not that you would need to add this in, but PV equals nRT is the ideal gas equation. It helps us predict and explain and simplify what's quite a complex system of a gas. But for a nature of science, you need to keep it general. So your answer here must be kept in more general terms.